everyone, welcome back to Xcoding with Alvian. This is my first video in 2022, and we're going to kick off strongly by keep on doing what we all love, which is building apps to enrich our world with software and technology. In this video, we're going to build a macOS menu bar app with SwiftUI to show real-time cryptocurrency price from CoinCap.io WebSocket server. In case you don't know about WebSocket, it is a mechanism to create a persistent long-run bidirectional connection between client and server. This is different compared to HTTP, which the client simply make a request, receive the response, and close the connection. Let me show you the demo of the final app that we'll build. Let me try to zoom in this menu bar area. You can enable this from the accessibility menu in the macOS system preferences. Here, it shows the Bitcoin and the real-time currency value as the server pushes the new data to our app. We have this green circle that indicates the connection status to the CoinCap WebSocket server. Now, let me click on the menu bar item to open the Popover view. The Popover view shows the picker with macOS radio group style for the user to select which coin to be shown on this menu bar item. The current price is also shown for each of the coin type in real time. Let me change by clicking other coin type. For example, Ethereum. Nice, the menu bar item got updated with the new coin type. And here we also have this button link for each of the coin type. So when I type on this Bitcoin, let me zoom out. It will open this coinmarketcap.com showing the Bitcoin data. For example, let me select Ethereum. It will open Ethereum. Okay, so that's it for the UI. In addition, we will also provide network reachability monitoring and simple reconnection logic to the server. To show you, let me try to turn off my Wi-Fi connection here. As you can see, when I turn it off, the circle got updated with the red color, and the offline text is shown. Let me turn it back on. Wait a bit. Okay, it automatically reconnect, and now the circle color turned to green, indicating we have successfully reconnected to the server to accept new price data. Let me try to zoom out. That's it for the demo. In this video, we are going to learn the several concepts. First, create macOS menu bar app that only act as agent without dock icon and main window. Second, configure NSStatusItem to add menu bar item. Learn how to customize the UI using SwiftUI base view. Third, configure menu bar item click action to show NSPopover with SwiftUI view as the content view. Fourth, create CoinCapPriceService. Use URLSessionWebSocketTask for creating WebSocket connection using native Apple API. We're going to utilize combined publishers for the view models to subscribe to the new connection state and coin price value, so it can update the UI accordingly when the states change. Fifth, manage long-run connection lifecycle, sending ping to the server periodically, monitor network change using Apple NWPathMonitor API, and handle reconnection to the server. Sixth, encapsulate all the states and domain for each view using observable object for the view model. And finally, building all the UI using SwiftUI. That's all the things that we are going to learn in this video. You can download the completed app from the GitHub repository link that I've provided in the description. And okay, without further ado, let's begin by opening Xcode. The minimum requirement for this project is Xcode 13 and macOS 12 Monterey. I am currently using Xcode 13.3 Beta 1 and macOS 12.3 Public Beta on my machine. Okay, let's begin by creating a new Xcode project here. And here, Select macOS from the tab and select this application template. For the product name, give it a name of crypto tracker and select your theme. Provide your own organization identifier. Interface is SwiftUI, and we can uncheck the use core data and include tests. And finally, just create the project. Now let's try to run the app. Okay, now the app runs and we have the main window here, this very small main window. And if you see here in the dock, we can see this crypto tracker being shown. As we will be making our app to be shown only as menu bar item, let's configure the project to achieve this. So here in the project navigator, select this crypto tracker and select this info tab and add a new key here and find application is agent. Okay, and the type of this is boolean for the value and change this to yes. Okay, now let's try to run again. As we can see now, there is no app icon on the dock anymore. Okay, next, let's remove the window that is being shown when the app launched. I cannot find any official Apple documentation on how to do this with SwiftUI based macOS app template. So let's do a bit of hack to achieve this behavior. Open this crypto tracker app.swift file and let's remove this and replace this with empty view and add the frame modifier of width of 0 and height of 0. Just ignore the alignment. And now we can delete this content view.swift file, move it to trash. Now let's try to build and run. Okay, when the app launch, there is no main window being shown in here, and we don't have it in the dock anymore. So that's it for making this app as a menu bar item only app. Okay, now let me make the Xcode full screen, close this sidebar, and next, to be able to set up the menu bar item in launch, we need to subclass NSApplicationDelegate and implement the setup in application that finish launching delegate method. So inside the project navigator, create a new Swift file, give it a name of appDelegate. At the top, let's import Coco and also import SwiftUI. And let's declare a class appDelegate that inherits from NS object. And let's also make this conform to the NS application delegate protocol. And now let's implement this application did finish launching notification method. Okay. For now, let's just print app did finish launch. Okay. So how can we connect this to the SwiftUI based app here? Because if you see here, this crypto tracker app, it uses this main keyword. So this will be the entry point of the app. So to do that, it's pretty simple. So Apple provide this NS application delegate adapter. This is a property wrapper that is used in app to provide a delegate from AppKit. Okay, it accept this argument, which is a type of NS application delegate, which is the appDelegate.self. This is our implementation of NS application delegate. Let's make this private var, give it a name of appDelegate. Okay, let's try to build, run this. And let's see here in the console, we can see app did finish launch is print successfully. So we can confirm that this app delegate, this application did finish launching method is invoked when the app launch. To set up the menu bar item, we need to make the NSStatusItem as a property of the app delegate. So let's begin by declaring a var status item with the type of NSStatusItem. This is an individual element displayed in the system menu bar, and make this as implicitly unwrap optional. Don't worry, as we are going to initialize this in application that finish launching. And let's organize the code from the start by creating an extension and put all the related logic to the configuration of the menu bar in here. So extension app delegate, let's create a new method, setup menu bar, and remove this print statement and invoke setup menu bar. And let's set up pragma here, menu bar. So by adding pragma, we can basically open this and then we can navigate our code easily here. Inside the setup menu bar, first we need to assign this status item property with ns status bar dot system dot status item. So this will return a newly created status item that has been allotted a specific space within the status bar. In our case, I won't be using dynamic size. I will be using a hard-coded width, which is 64. So if your app has a dynamic length, the content is dynamic, you can also pass the as status item dot variable length. This is a status item length that dynamically adjusts to the width of its content. But when I tried this, it doesn't really work. So for this tutorial, I'm just going to use 64. Okay. Next, how can we configure this status menu bar item? First, there is an expose button that we can use. To get it, we need to use guardlet menu button status item dot button. This is an instance of NS status bar button, and as you can see, it is an optional. So in case of nil, we just return. So actually, using this NS status bar button, there are two properties that we can customize in here, which is the title. Let me just hard code it now, Bitcoin. And the second one is the image. So we can assign an NS image to this property. So let me try to assign NS image using a SF symbol provided by the system. So Apple provide this Bitcoin sign.circle. Okay, now let's try this first. As you can see here in the menu bar, it shows this Bitcoin symbol, but the title is not being shown. So actually, I think we cannot set this property both together. It must be only one of them at a time. So for example, when I remove this image, it will show this Bitcoin as the title. This is a very limited actually, because we cannot customize the view the way we want. So next, let's handle this by customizing the menu bar item view using a custom SwiftUI view. Okay, I think the text looks too small. Let me increase the font size here. Okay, I think this is good enough. And let's create a new SwiftUI view first. Select SwiftUI view and give it a name of MenuBarCoin View. Okay, for now, let's just declare an edge tag at the root level. And let's resume the live preview. And let's add a spacing of 4 here. And let's declare an image first for the status indicator circle. I'm just going to use this FSF symbol circle.fill. And let's give it a foreground color. Let's hardcode this to green for now. And beside the image, let's declare another VStack alignment of trailing and spacing of -2. Let's declare a text inside the VStack. Let's just hardcode it now. Let's say Bitcoin. And let's also add another text and pass $40,000. Okay, and let's set the font for both of them as caption here. Okay, I think this looks good for now. Let's navigate back to the app delegate to .swift to configure this. To add a custom view, we need to access the window.content view property inside this NSStatusItem. Sadly, Apple does not expose this window as public property. Luckily, we can access it using value for key method, passing window string as the key, then cast the value to NS window. So first, let's declare a private lazy var content view with the type of optional NS view, and let's declare a closure that will be executed. Here we just need to declare a let view, and then let's open a parenthesis status item dot value for key, passing this window string, and then let's cast this optionally as NS window. Okay, as this is optional, we need to add this question mark also here, and then dot. So here, we can access this content view property. Okay, now we have the content view of the NSStatusItem. Don't forget to return this view. Okay, so in this setup menu bar, let's add additional let here in the guard. Let content view equal to self.content view. Okay, now we have the content view here. First, we need to declare a view, give it a name of hosting view, and initialize this NS hosting view. This is an AppKit view that hosts a SwiftUI view hierarchy. So this is actually a subclass of NS view from AppKit. And here it accepts this root view. And here we can pass SwiftUI base view. In this case, let's pass MenuBarCoin view. And next, we need to add this to the menu button. We are going to use auto layout. So first, let's use hosting view dot translates authorizing mask in the constraints. Let's assign this as false. And next, we are going to use this content view and invoke add subview, passing this hosting view. And let's configure the auto layout programmatically using this ns layout constraint dot activate. Let's pass all the constraints in an array. So we're going to anchor all of these hosting view edges to the content view. So let's do it. Hosting view dot top anchor dot constraint equal to content view dot top anchor. Okay, let me copy this 3 times. Okay, and update this top right, change this to right for the second element, and for the third element bottom here, and for the last element it will be left anchor. Okay, we have constraint to all the edges. And next is just let's try to build and run here. As you can see here, me zoom. It shows this menu bar coin view successfully inside the menu bar item. Nice, this is a good first step. Next, let's add a click handler for the menu bar item, so it can invoke a method when the user clicks on the menu bar item. Below the setup menu bar method, let's declare a func menu button click, and in here we need to add objc keyword. Why? Because this will use Objective-C target action selector mechanism. So inside the setup menu bar, we can simply assign this menu button dot action, the default action message selector associated with the control. Okay, and then let's use this syntax selector for the Objective-C. We can pass Objective-C method here. So let's pass menu button click. Okay, and inside this menu button click, let's print statement menu bar item click. Now let's try to run this, and let's try to click on this menu bar item. Nice, the menu bar item click print statement is being logged in here successfully. Okay, let's stop. Next, let's create the popover view that will be shown when the user click on the menu bar item. So first, let's create a second SwiftUI view here. Give it a name of PopoverCoin View. Let's replace this hello world with vstack at the root, and let's pass spacing as 16. And here inside this vstack, declare another vstack without any spacing, and declare a text, pass Bitcoin, and here at the font modifier, passing large title, declare second text, pass $40,000 hard-coded string, and set the font as title and make it a bit bold. Okay, now let's add a divider. Declare a button with the title of quit, and inside the action closure, let's invoke this NS app, the global variable for the shared app instance, and then we can invoke terminate. This will basically kill the process of the app. Okay, that's it. We'll implement the picker later to select the coin types when we have created the CoinType model in the coin price service. Okay, let's go back to the app delegate for now. Okay, so inside this app delegate, first we need to declare an instance of NSPopover here. So let's just use let for this popover and initialize NSPopover. Means to display additional content related to the existing content on the screen. Just initialize this with the default value. And let's create another extension for app delegate. And this time, let's give it a pragma of popover. And let's declare a method setup popover. Make sure to invoke this here in the application did finish launching method setup popover. And inside this setup popover here, first let's set up the popover.behavior, and let's assign this transient The system will close the popover when the user interacts with a user interface element outside the popover. So this will basically dismiss the popover when the user tap outside of the popover content view. And next, popover.animates. So let's make this to be animated when it appears and disappears. And next, we need to set the content size. And for this, we are going to hardcode the CG size. And I'm going to pass a width of 240 and height of 280. Okay. So just for your info, this popover content size is not dynamic. If you want to make it dynamic, you need to configure it by yourself. And next, let's assign the content view controller by initializing NSViewController. And finally, over the content view control, we need to set the content view. Sorry, not the content view. It should be only the view. And here we need to assign it with NS hosting view. Okay. So with NS hosting view, we can pass the SwiftUI base view. In this case, let's pass the PopoverCoin view. And let's add the frame modifier, max width of infinity. So this will make sure it takes all of the horizontal and vertical spaces given by this content view control view. Okay. And for the max height, let's also pass infinity and add a padding here. Okay. And now let's try to build. Okay, the build succeeded. Next, we need to make this popover show when the user click on the menu bar item. So let's remove this menu bar item click print statement in here. And first, let's check if the popover is shown is true. Then we just invoke perform close. Okay, to make it disappear. And then we just return. So continuing on, first let's grab the menu button from the status item button. We will be requiring this status item button as an anchor to the popover view. Okay. And we can simply invoke popover.show. For the relative to, let's pass menu button.bounce of menu button itself. And for the preferred edge, let's pass maximum y. Okay. And let's make this popover become the main focus by using this content view controller.view.window make key. This will become the key window. Okay. Now let's try to run this. And let's click on the menu bar item. Nice, it successfully shows the popover coin view. And let me click this quit. Okay, it kills the process of the app. So I just want to show you in here. If you take a look at the Apple menu bar item here, if you can see there is no arrow in here, but in our app here we have this arrow, right? So let's try to do a little bit of hack because I cannot find any official documentation on how to do this. So let's do a little bit hack to remove this arrow. So basically the idea is to create a positioning view using the menu button.bounce as the frame and then edit a subview of the menu button. Then we will use this positioning view as the anchor of the popover. Let's try to see and implement this in code. Okay. So inside this menu button click here, after the guard, let's declare a let here, give it a name of positioning view. And let's initialize a NS view passing the menu button dot bounce as its frame. And let's add a identifier for this positioning view so we can remove it later when the popover dismisses. Let's use this NS user interface item identifier. Okay, and let's pass the identifier, give it a name of positioning view. Okay, and basically we can just add this as the sub view of the menu button as this positioning view. Okay, and next we need to change here. We need to change the bounds of the menu button after the invocation to popover.show. So this will basically move the positioning view away. Menu button dot bounds. So we're going to offset this. Offset by, for the x, just pass 0. And for the offset of y, we need to use the height of the menu button bounds. Okay, this will move the positioning view away. And I think we can try this now, at least. Let's click on the menu bar item. Nice. The arrow is now, if you can see now, right? There's no arrow here in the popover. Okay. And now we need to handle a case where we need to remove this positioning view when the popover dismisses. Okay. Because we don't want to keep adding it to the view when the button click. So next, let's make this app delegate to be a delegate of NSPopover delegate here, to be the delegate of popover. So let's go to the setup popover and assign the delegate property as self. And we can simply implement this method popover did close. This will be invoked when the popover close disappear. Here we need to find the positioning view inside the status item button, the menu button, using that identifier that we have created before. So status item that button, we need to check all the subviews, and we're going to use first to find the first element in the collection that match this closure. So $0.identifier equal with NS user interface item identifier raw value is positioning view. Make sure this is same positioning view. Okay, and finally we can invoke positioning view and remove it from the super view. Okay, let's run this. Let me put a breakpoint here. Okay, it shows here, and let me try to tap on the other area. Okay, what's that area? Okay, it triggers this breakpoint, and we can see that the positioning view instance in here. We can also PO this using the LDB debugger. Okay, it successfully find this NS view with this identifier, so it can be removed from the super view. Okay, let me stop this and remove the breakpoint. Okay, we have successfully implemented the popover and the menu bar. So the next step is to implement the CoinCapPriceService. Before we create the CoinCapPriceService, we need to create all the models related to our app domain. So first, let's create a new Swift file and give it a name of CoinType. Okay, and in here we simply declare enum CoinType and make the raw value a string, and let's also make this identifiable, as we are going to use this inside the picker. And let's make this case iterable so we can get all the cases inside an array. And let's declare the first case Bitcoin, second one Ethereum, one Monero, and Litecoin, and finally Dogecoin. So for this app, I'm hard coding all of these like 6 cases, but actually you can query all the coins. But in our use case, in our app, I don't want to do that. You can check the documentation from the CoinCap.io that I provided from the link at the description if you're interested to add more or different coin. And we need to implement this compute property of ID, make the type as self, and then we just simply return self. Next, let's create a computed property for our URL with the type of URL. This will be the URL that we are going to use for the button link. So it can navigate to the CoinCap.io website to see the more detailed data and charts. Okay, here I'm going to pass this string https coincap.io/assets. Let's pass the raw value using string interpolations. Okay, and let's make this force unwrap. And let's create the property description, completed property with a type of string. We're going to use this to show the title of the coin type in the UI. Here we just return raw value and invoke capitalized. Okay, we have created the coin type. Just make sure to build. The build succeeded. Next, create a new save file and then name it as coin. So this is the model that we use to represent the data that we get from the CoinCap WebSocket server. So declare coin, and this is very simple. It has two properties: name with a type of string and value with a type of double. Okay, that's it for all the domain models for this app. Now let's create a new file. Service. So this is the service to create long-run persistent WebSocket connection to CoinCap server with Apple URLSessionWebSocketTask API. This API is introduced by Apple in iOS 13. So if your app still needs to support iOS 12 and below, you might be considering using third-party library such as Starscream to create WebSocket connection. And to communicate back with the few models that will use this service, we are going to expose two public combined publishers for the coins that got pushed from the server, as well as connection state that got updated whenever the connection status to the server changes. Okay, so let's begin by importing combine. This is a framework provided by Apple for using publisher and subscriber pattern in our app. And next, we need to import network module. This will be used later when we want to implement monitoring network changes. Declare a class now. Give it a name of CoinCapPriceService. Make it inherit from NSObject. We need this to be an inheritance of NSObject because later we will become a delegate of URLSessionWebTask delegate. It requires the delegate to be an NSObject subclass. And the first property we are going to declare is private let session. It will be an URL session. Let's initialize it with the file configuration. We are going to use this to generate URL session web task using a URL. And next, let's declare a private var WS task with type of URL session WebSocket task. We need to make this optional because every time we got disconnected from the server because of connection lost, there won't be a way to resume or reconnect back using the same instance of this task. So every time we need to create a new task and assign this to this WS task property. So this needs to be a var. And next, we are going to declare a combine publisher. So you may be wondering if you never use this kind of combine or maybe RX Swift. So basically, those kind of framework provide a way to have a subscriber, publisher, and subscriber pattern in our app. So basically, a publisher can emit a series of value over time. And basically, we can subscribe to that publisher, and then every time a new value arrive, it will invoke the closure passing that new value. And there are also other things that we can do using the operators, such as we can combine multiple publisher, ship multiple publisher, merge, filter, and map. So let me just show you in this app on how to use it. Okay, first one is publisher, and let's give it a name of coin dictionary subject. So we're going to initialize it with this current value subject. This is a subject that wraps a single value and publish a new element whenever the value changes. So what basically a subject? Basically a subject can be a publisher, and then it can also subscribe to another publisher. And this current value subject can accept an initial value, and you can also access the current latest value. And there's another kind of subject, which is the pass-through subject. But this pass-through subject doesn't accept initial value, and we cannot access the latest value from a property. So in our use case, we want to use the current value subject to access the current value. And so we need to provide the type of value, in this case using this generic. And we are going to use this dictionary of string key and value of coin. And the second parameter in this is a failure. And in our case, this publisher will never emit or throws. It never throws an error. So we are going to use this special keyword never. And basically we can initialize this passing an empty dictionary for the first time. Second, let's declare a computed property to access the value of this dictionary, this subject. Give it a name of coin dictionary string coin. Basically, we can just access it using coin dictionary subject dot value. This is the current value wrapped by this subject. Okay. And the next publisher is the connection state subject. We are going to also use current value subject, but the value type will be a boolean. This is simply a boolean indicating whether we are connected to the CoinCap server or not. And it also never emits an error. And the default value, it will be false. And let's also declare a private var to access the current value is connected with the type of boolean. We simply can access the connection state subject dot value. Okay, we have all of our initial properties that we can be used to make our connection. And before we create a connect method, let's create this dinit, custom dinit. So basically it's a good practice if you have a publisher here to always tell your downstream, all the subscriber, that whenever you already want to deallocate this, you will send the completion. So the system can free up the resources. So I'm just invoking this send completion finish. This will indicates to all the subscriber that this publisher will never emit new value again. Okay, so maybe the subscriber can do a little bit of cleanup. And next is this connection state subject dot send same finish. It might be not required for our app because this CoinCap price service will be always exist in the lifetime of our app. But if this service can be deallocated in the runtime, then I think this is the best practice that we should adopt to clean this up. Okay, now let's create a func connect and implement this. Okay, so inside the body, let's declare a let and give it a name of coins. Here, let's access all the cases from the coin type using the all cases. And basically, we need to map this to an array of string. So let's use this map and use the raw value. And next, we need to make this array to become a string using this join, a comma separated string. You can use this join and pass comma. So basically, it will become like this: Bitcoin, Ethereum, Litecoin, and so on. Okay, and now let's create the URL that we are going to use to connect. Let's declare URL string, and for the base URL, the scheme is a bit different compared to the HTTP protocol. Here we are going to use this WSS as the scheme, and WS, the address is ws.coincap.io, and here is the path prices, and we need to pass the URL param. In this case, the first URL param is this assets, and the value here. Actually, we can use this all to get all the coins, but in our case, we don't want all the coins to be sent over the WebSocket connection. It will be too large. In this case, we only want these coins, right, that we declare. So we're going to pass the strings that we have created above. Okay, this is the URL. Let's make this, unwrap this force unwrap this, and we have the URL. Now we can assign the WS task with URL session dot WebSocket task with URL, passing the URL. And let's also set the task delegate as self. And for that, let's create a extension CoinCapPriceService URL session WebSocket delegate. Okay, so actually there are two methods provided here that will be invoked. So it open with protocol when it is connected to the server, and the other one when connection closes. Okay, for now let's just ignore the implementation. We'll implement that later. And finally, we can simply invoke task.resume to begin the connection. That's it for the connect method. Okay, so before I continue, let me show you the data, the format of data that we will receive from this server. So here I'm using this Postman, and then I already using this same address, os.coincap.io. Here the assets is only Dogecoin and Bitcoin. Let me try to connect here to this WebSocket server. Okay, it's connected, and now the data is coming. You can see here Bitcoin, Dogecoin. So basically this is a JSON formatted string, and basically we want to convert this to data and convert this to a Swift dictionary, and finally we need to modify this so it can become a string. So this string key itself will be Dogecoin or Bitcoin, and the value will be an instance of coin. We'll be initializing that using this name and the value. Okay, that's basically the simple explanation. So let's start implementing the receive message method. Okay, so let's make this private func receive message. And to receive a message using our URLSessionWebSocketTask, we can simply invoke wstask.receive. So this is a closure. We just use a trailing closure syntax here, and let's capture self as weak to avoid any return cycle. And the parameter, let's name it as result. This is a result type. And if you see in here, I think the type is URLSessionWebSocketTask.messageEnum for the success case. Okay, so first let's use guard let self equal to self to unwrap this. And continuing on, let's just use switch on the result. There will be two cases, success with the value. Sorry, let's give it a name of message. Let's just break for now. And next is failure. Give it a associated value name error. And then let's just print here in the error case fail to receive message. And let's use string interpolation to access error.localized description. Okay, optional type. Okay, so this is optional. We need to add this. Okay, this is for the failure case. And now for the success case, we need to use switch here. This is an enum, this message. And the first case is string. Our socket message that contains a string. Okay, this will be invoked in our use case. As you can see here in Postman, this is a string. Let's just break. And second one is data in case of binary data. Let's assign a short value of data here. Let's just break for now. And for the default, let's break. Okay, so basically let's create another method to basically decode the message and convert it to this dictionary. Let's give it a name of private func and the on received data, I think it's better, on received data. And the name, the parameter is data, and the type is data, a binary data. Okay, so for the case data, we can simply invoke self.onReceivedData, passing the data. And in case of string, we need to do conversion here. If let data and text, can use this data using. For the encoding, let's use UTF-8. This is the most common one. And let's invoke self.onReceivedData, passing the data. Okay, that's it for the received message. Now we need to implement the onReceivedData. First, we need to convert this data to Swift dictionary. So let's just use this guardlet here, give it a name of dictionary. And we need to prefix this with try, make this optional, failure. And we can use this JSON serialization, JSON object with data, passing the binary data here. And we need to cast this as string. Key and value is string, as you can see in here. Okay. If it fails, we just return. Okay. Now we have the dictionary, but the type is still string, right? We need to convert this to string coin. Okay. So first, let's declare a new property, var new dictionary. Give it a type of string coin dictionary. And let's do a for each on the dictionary that we receive from the server. For each key value. Okay. First, we need to declare the let value, and we need to convert this to double by simply passing this value. This is current string. We need to convert this to double. Okay. And let's provide a default value in case it fails of 0. And finally, we can use this new dictionary and then set the key, assign the coin, that initialize a coin. For the name, we can simply pass key dot capitalized, and for the value, let's pass this value that we have converted to double. Okay, now we successfully map this dictionary to this string coin. Now we need to, because this will getting pushed over time, we will have a previous data, right? So basically we won't overwrite the current data. We simply will merge, because as you can see here, the data comes, not all the coins will come in each data. So for example, we got this. If we override it, the data for the Dogecoin will be removed. So we will basically merge the dictionary. Now, for example, in this, it will be using this, and we still have this Dogecoin. Okay, let's see it in action. So let's declare let merge dictionary, and basically we can simply invoke coin dictionary. This is the current value of the dictionary, this current value subject, and we can simply invoke this merging. Okay, create a dictionary by merging the given dictionary into this dictionary. Okay, and basically provide a closure. This is the old value and this is the new value. Basically we need to choose whether to use the old value or the new value. In our case, we want the new value, so we return new. Okay, and finally we need to publish this new dictionary to all the downstream subscribers. We can access this using coin dictionary subject dot send and pass this merge dictionary. Okay, I think we need to try to build this. Missing argument for parameter 1 in call. Okay, oh sorry, I forgot to pass the new dictionary. Okay, so this is the current, merging that with the new dictionary. Okay, we can simplify this syntax actually by just using this $1. Okay, okay, we have successfully implemented the on received data. Now let's try to integrate this and test this a bit. And let's add additional print statement, I think, in here. So let's print here receive text message, and then let's just print the text. And here also print receive binary message, and let's print the binary data. And let's try to, before we can run this, we need to add something in here in case of success. So basically the way this receive message works, so once this invoke, we get the data. For any new data that will be pushed from the server, we won't be able to use the same, it will be only invoked once. So basically, to be able to keep on receiving new data pushed from the server, we need to invoke this again here. So this is a bit of recursive, but that is currently how the URLSessionWebSocketTask work on iOS. Okay, so remember that only for this receive, only one message. Okay, for any new message, keep on invoking the receive message. Okay, so let's try to go to the app delegate in here, and let's also add this func setup CoinCap service. Okay, and let's declare the var CoinCapService and with the type of CoinCapPriceService. Okay, I think we can make this a sled and then just initialize this using a default value. Okay, it has no dependency currently. So basically here, let's invoke this first. Set up CoinCapService in the application that finished launching. And let's invoke CoinCapService.connect. Okay, now let's try. Okay, just build this. Okay, looks like it fails. You may be confused, right? So actually on macOS, by default, when you're creating a macOS app using Xcode template, you won't be able to create an outgoing internet connection. So basically we need to go to the project setting in here and go to this signing and capabilities tab inside this app sandbox section. As you can see here, network, we need to basically enable this, check this outgoing connections client. Okay, this will enable the internet access for this app. Okay, let's try it again. I think it's being printed. Oh, sorry, one thing I forgot. So inside the connect method, we need to invoke receive message. Okay, to get the first message initially. Okay, now we can see here the data are coming here in real time. Nice, right? Okay, I think we have successfully implemented the connect method. Now let's move on to the second task, which is to manage the life cycle of this connection. Okay, so this next task is to manage the connection life cycle of the URLSessionWebSocketTask to the server. So we cannot predict the stability of internet connection, right? The users might have bad or lost internet connection. Or maybe the server can also close the connection to ask the client. Also, to maintain a long-run persistent WebSocket connection, we need to send a ping periodically to the server. And basically, we need to create a reconnect mechanism to manage this connection life cycle. We'll be implementing a very simple and naive approach to handle this. So our app can automatically reconnect in case of connection loss, without adding any UI element and manual intervention from the user to refresh the app. Let's begin by implementing this URLSessionWebSocket delegate method, these two methods. The first one is this URLSessionWebSocketTask did open with protocol. So this will be invoked when we have successfully connected to the WebSocket server. In this case, we want to update the connection state subject by sending a new value of true, indicating that we already connected to the server successfully. The second one is this URLSessionWebSocketTask did close with. So basically, this will be invoked when we cancel the current task. So when we call this cancel, it will disconnect from the server. But actually, when I try this API, in case I turn off the Wi-Fi and the connection got lost, this URLSession did close with never got invoked. I don't know the reason of that. So we cannot 100% using this method to update the disconnected state. But I think we still can update it. There's no problem on doing that. But we need to handle in case dating the connection state in case the sudden internet connection loss. And now, first let's begin by declaring a func here. Give it a name of clear connection. So this will basically handle disconnect and clearing the task. Here we simply invoke WS task, cancel, and set it to nil. Okay. And here we can simply update the connection state subject we already know here, we can already cancel and set this to nil. So even though this won't be getting invoked, we still can send false because we set this to nil. Okay, that's it for the clear connection method to disconnect. Next, we'll implement the send ping schedule mechanism. So you may be wondering, why do we need to send ping periodically to the server? The answer is, for any long-run connection between a client and server, ping is used to make sure that the connection to the server is still active, it's not broken, by making sure we got a response back from the server. This also works in reverse. When a client sends a ping, the server will know that the client is still active, send the pong back, and maintain the connection. So basically in this method, we are going to send the ping periodically each 5 seconds. This is a bit aggressive, but it should work for this tutorial. This is an area which you can optimize later if you want. Also, I mentioned before that the WebSocket delegate method is not being invoked in case of sudden internet loss. So this method will automatically handle this. It will automatically trigger this to false. We'll see that later when you implement this. Okay, so let's declare a private function. Give it a name of schedule ping. First, we need to capture the identifier of the current URL session web task using this task identifier. This is an identifier uniquely identifying the task within a given session. So every time we create a new instance of this, it will be assigned a different task identifier. Okay, so let's provide a fallback value of -1. And now let's use dispatch queue main as sync after. So we'll schedule the closure to be executed after 5 seconds. Okay, and make sure we capture self as weak to avoid any return cycle. Let's use guard let to unwrap self. Let's also get the task from self.ws task, and we are going to make sure the current task identifier here equals to the identifier that we have captured 5 seconds earlier. Okay, only if that equals, both of them equals, we're going to continue. Okay, then finally, in case this guard fails, we just return. Okay, continuing on. First, we're going to check the property in URLSessionWebSocketTask. There's this state, the current state of the task, whether it's active, suspended, or in the process of being cancelled or completed. Okay, so here we're going to check if this is running. We are going to send the ping using task.sendPing. Okay, and we need to pass the closure. It has one parameter error in case of error. So let's just print here pong ping fail. Let's print the error. Okay, and let's also print here ping send ping. Okay, and we're going to make sure after we send the ping, we need to call this method again. So it will keep on calling this method every 5 seconds to schedule the ping and to check the condition of the statement. Okay, schedule ping. So if the task.state is not equal to running, so maybe the connection got lost, we're going to simply do some reconnect mechanism. Okay, and let's declare the reconnect. It's going to be pretty simple actually. Just need to invoke clear connection, and let's invoke connect. Okay, and make sure to invoke this reconnect in the else block. But actually there is one minor issue actually. This task.state equals to running, right? This doesn't get updated immediately in case of sudden internet connection loss. There will be an internal WebSocket timeout, connection timeout, which is around 30 seconds up to 2 minutes. Only in that between the timeout, this task.state will change to not equal to running. And I think that timeout is too long for us to wait. We need to just disconnect immediately in that situation where the sudden internet connection loss happening. So we need to have some kind of trick in here. So as you know, this is triggered every 5 seconds, right? So the strategy in here to have a ping try count, a counter, where we will increment this every time we send a ping. So in that case, when the ping try count is greater than 2 after 10 seconds, in that case, we will reconnect. Okay. If it is still running and the ping try count already greater than 2. Let's see how it is in action. So here, let's declare a private var ping try count. I'm going to set the default value as 0. And in here, in the send ping, I'm going to increment this ping try count by 1. Okay, let's print this also in here using the string interpolation. Okay, and here in this if statement, right, we need to add this self.ping try count is less than 2. Okay, so if it is still less than 2, we still make this ping. Okay, but if it is already larger than 2 after 10 seconds, it's still running, right, we will just reconnect. Okay, and we need to be careful in here. We need to reset this ping try count in case of the ping success, we got the pong back. So just make sure the current identifier first, we need to make sure we capture this weak self to avoid an inheritance cycle. And we're going to check this self.task ws.task.task identifier equal to this identifier, the first one that we capture. Okay, only in that situation we will reset this. Okay, this will avoid any rust condition in case we already reconnect and this got invoked. Okay, now we will also reset the ping try count inside this clear connection. Okay, ping try count equal to 0. Okay, now let's see, we have implemented the schedule ping. We need to invoke this schedule ping in the connect. Okay, okay, maybe now we can test this. Let's build and run. Let's wait 5 seconds. Okay, we got this ping, send ping 1. Okay, so every 5 seconds it will try to ping. So in this case, because we have a stable internet connection, it will keep on pinging, right? So now let me try to disable the internet connection, right? First we need to check this whether this will got invoked, right? Let me disconnect. Okay, as you can see, right, this is not getting invoked. But if you see in here, this reconnect, right, this reconnect will be invoked. Right, as you can see, it will try to keep on reconnecting. And so basically this is it. Now let me try to resume this and let me try to bring the Wi-Fi back. Okay, let's see whether the new data will come or not after like 5 seconds, right? Okay, as you can see here, we are getting reconnected to the WebSocket server and new data are coming again. So yeah, we have simply implemented this Very, very simple reconnection mechanism. But if you see in here, right, this is not very good because if we turn this off, it will still keep on trying to do some reconnect, right? So, but in this situation, we already know that there is no connection, right? There's no internet connection. You should be able to not just keep on scheduling this, right, every 5 seconds. So let's try to implement a monitoring mechanism to detect the network change. So when the network is off, we will simply keep disconnect, never keep on reconnecting. And when the connection is back, we will connect to the server. Okay. Now let's try to implement it. The first thing that we need to do is to declare this private LED monitor, and we are going to use this API NWPathMonitor. I think this was introduced by Apple in iOS 12. Okay, we are going to monitor all the interface, Ethernet, Wi-Fi, all of them, and this is from this network module that we have imported. So let's create a method here. Start monitor network connectivity. Okay, it's very simple here. We just need to assign a closure path update handler that will be invoked every time the network changes. Make sure to capture weak self here to have an unwritten cycle. The parameter is path, and basically let's just use guard let on self first. Next, let's check the status. Okay, so basically we can use this satisfied. So the path is available to establish connection and send data. Okay, and we also need to check if the task is equal to nil. Only if this nil is satisfied and it is nil, we are going to connect. Okay, and next we're going to check if path.status is not equal to satisfied. Okay, so it means we getting disconnected from our network, right? In this case, we just want to invoke clear connection. Okay, now let's try to, before we can start this, we need to invoke monitor.start passing the queue. Make sure we are using the same queue as the one we are using in the schedule ping. And I think this should be a serial queue, right? To avoid any rest condition. Okay, so let's go to the app delegate. Let's go to the app delegate, and inside the setup CoinCap service, let's invoke CoinCap service start monitor network connectivity after the connect. Okay, let's see whether I make some mistake or not. Think okay, now let's try this. Just let me again. Okay, let me put a breakpoint in here and in here. Okay, so let's try. Okay, we got the data. Now let me try to turn off my Wi-Fi. Okay, the path.status has been updated to not satisfied, not equal to satisfied. So in here we just clear the connection, and let's see whether this schedule ping will be invoked to keep on reconnecting. Yeah, I can see that it's not being invoked periodically now. Now let's turn the Wi-Fi back on. Okay, the path.status is satisfied and the invoke is connected. Nice. Let's resume. Let's see whether the new data is coming. Nice, I can see the data are coming. Okay, I think we have built a quite robust mechanism to handle this network connectivity and connection lifecycle for our WebSocket task. With this, we should be able to handle connection loss and when we are connected back to the network. Okay. Now let's implement the user interface by creating all the view models that will connect to this CoinCap price service. So let's begin by creating the view model for the menu bar coin view. Let's create a Swift file and name it as MenuBarCoin ViewModel. Okay, and let's import SwiftUI and let's also import combine. Okay, and let's declare the class MenuBarCoin ViewModel. Make it implement the observable object protocol. And now let's declare all the instance properties. We will have the first publish property here. Let's make this private set. Okay, and give it a name of name with the type of string. And second one is also publish private set, and give it a name of value with the type of string. And the third one is a publish private set, and this is color with the type of color. Okay, this will be used for the color for the circle for the connection state indicator. Okay, now we need to create the fourth property, and I'm going to use this app storage property wrapper. Basically, this reflects a value from a user defaults and invalidates a view on a change in a value. Okay, so basically the internal storage of this is a user defaults, and we need to provide the key. I'm going to pass selected coin type. This key will be used to store in the user defaults, and let's make this private set var selected coin type. Okay, and let's assign CoinType.Bitcoin as the default value. So I'm using this app storage because inside the PopoverCoin view, I will also be using this app storage and pass this as a binding in the picker. So whenever the user change the selected coin type inside the picker, this will also get updated. Okay. And next, let's declare a private LED service with the type of CoinCapPriceService and declare a private var subscriptions and initials a set of any cancelable. So basically, when we subscribe to a publisher, it will return a subscription that we need to store, and we also need to handle the cancellation, the removal of that subscription. So in this case, we're going to store all the subscription inside this set. And when this class got the initialized, it will automatically set this to nil and remove the subscription from a publisher. Okay, now we need to create the initializer. But before we create the initializer, I want to create another private LED currency formatter, so I can format this value using the currency formatter. Okay, the type is number formatter, and let's pass a closure that we can configure. Here, let me initialize a formatter, and I can use number formatter and set the formatter dot number style. Number style is currency, and next set the maximum fraction digits to only 2, and set the currency code as US dollar, USD, and I'm going to show only the dollar sign inside the menu bar. So I'm going to use this currency symbol and I'm going to pass this dollar sign. Okay. Now let's create the initializer. Name is be the type of string. Let's provide the default value of empty string. Value is also a string. Let's also assign the default value of empty string. And color, the type of color, we'll set the default value as green. Next, we have the service, which is the CoinCapPriceService. Let's also assign the default value. Okay. Okay, now we have the initializer. We can assign all these parameters to the associated instance property. Name, value, self.color equal to color, and self.service equal to service. Okay, let's try to build now. Okay, forgot to return the formatter inside this initializer closure for the currency formatter. Okay, for the subscription, we don't need to initialize. We already provided the default value of empty set. Okay, now we have the initializer. Next is let's declare this func, give the name of update view. Okay, let's pull all the logic to update the view in here. Okay, so first let's grab the coin that we are going to show. So basically we are going to use this CoinCapPriceService. Check this. Give me a second. It can access this. Let me check. So actually I make a mistake here. This should be public. This should be public. This also should be public. So all of these 4 properties will be exposed to the outside. Okay. So basically now we can access the coin dictionary, and basically this is a dictionary. The key basically is the selected coin type dot raw value. Okay, the name of the coin type. And next, let's assign this name publish property using this coin, because this can be nil in case there is no data for that coin in this service. It will be an optional. Okay, so we need to provide a fallback. For the fallback, let's just assign the selected coin type dot description. Okay, and next let's check whether the service is connected. In case it is connected, let's unwrap the coin in here, this coin, and also invoke self.currency formatter string from. Okay, so this accept as an instance of NS number. We need to initialize NS number passing coin.value. Okay, so if we successfully unwrap all of this, we are going to assign self.value as value. Else self.value, just let's pass updating. Okay, else if it is not connected, we are going just to show the offline text. And finally we need to set the color. Check the surface where it is connected. If it is connected, we are going to use this ternary operator. We are going to set this to green. In case it's disconnected, we're going to set this to red. Okay, we have the update view. Next, we need to implement the subscription to these publishers, so we can react whenever a new data is being pushed from the server. Okay, to do that, let's create a method subscribe to service. Okay, so to subscribe using combine, we can grab the publisher first, the coin dictionary subject. Okay, and this is one of the cool feature that from combine, that we can combine multiple publishers into one single pipeline. Okay, so in this case, I'm going to use this combine latest. Subscribe to an additional publisher and publishes a tuple upon receiving output from either publisher. Okay, so simply I'm going to pass another publisher, which is the connection state subject. So to subscribe, I can use this sync. Attaches a subscriber with closure-based behavior to a publisher that never fails. Okay, because our both of the publisher never emits an error, we can use this sync receive value. And as you can see, it passes us the tuple here containing the coin dictionary as well as the connection state. In this case, I'm just going to ignore this, okay, because we can access the service properties from here. This coin dictionary and this is connected. Okay, we just want to know whether a new value is coming from either of these. And basically here, let's capture self as week and then invoke self.updateView when one of the publisher emits a new value. Okay, and finally this will return a subscription that is cancelable, and we can store this inside the subscriptions, this set of any cancelable. So when this object got the initializer, this get the initialized, it will automatically remove all the subscription from the publisher. Okay, try to build. Okay, the build succeeded. Now let's try to plug this inside this menu bar coin view. Okay, let's make this as an observe object and give it a name of view model with the type of menu bar coin view model. Okay, and let's update this to use the view model. You can pass color in the foreground color modifier, and inside it, this text we can pass the name, and here we can pass view model dot value. Okay, looks good. And the preview, let's pass this view model. In this case, let's just initialize it. We can pass Bitcoin value $40,000, color green, and service. Let's just ignore that because we already provided the default value in the initializer. Okay, let's try to build. The build failed. Let's see. Okay, now we need to inject the observable object inside the app delegate. So first, let's create an instance property for the menu bar coin view model here with the type of menu bar coin view model. Make this implicitly wrap optional, and here we can simply initialize menu bar coin view model. Here menu bar coin view model. And here let's just pass the service, which is the CoinCap service. Okay, now we need to pass this here in the menu bar coin view initializer. Let's pass the menu bar coin view model. Try to build. Okay, the build succeeded. Now we have to test this and see whether this is working or not. Okay, as you can see, we have this indicator, but we don't have any tags. That is a bit weird. We need to check what's the mistake that we make. Menu bar view model. Okay, let's put a breakpoint in here. Okay, now I got the problem. We never invoke this subscribe to service. Okay, so let's go to the menu bar coin view, and basically we need to add the on peer. Okay, appear modifier. So this code will be invoked when the view appear. In this case, I'm going to invoke ViewModel dot subscribe to service. Let's try again. Okay, nice. We can see this circle is green and we have this Bitcoin. And as you can see, let me try to zoom in. Okay, here's the value and it got updated. Nice. Every time a new data is pushed from the server to us. Amazing, right? Okay, now it gives an error. If you see, publishing change from the background thread is not allowed. Okay, because this happened because if you see in here, MenuBarCoin ViewModel, so this thing actually is being published in a background thread, and inside here you can see that we are updating the view. And whenever we update a view, must always happen in main thread or UI thread. Okay, that is the number one rule. To handle this, we can use this simple operator. Okay, receive on. Okay, basically it specifies the scheduler on which to receive the elements from the publisher. And here we can simply pass dispatch queue.main. This will be the main thread. So this code inside the sync will always be invoked inside the dispatch queue main, which is always be the UI thread. Okay, let's try again. Okay, let's see. Okay, got updated. And as you can see, there is no the thread error is not there anymore. Okay, this is amazing, right? This combine is very simple and we can simply build a reactive app using this combine. And if you are interested to about this, right, SwiftUI itself uses combine as its foundation for the state and binding and that observable object. Okay, so it is being used by Apple also to build the SwiftUI. Okay, that's a bit of context for you. Now we have implemented this menu bar point view. Now let's implement the Popover coin view model, right? Okay, Popover coin view model. Let's create a new C file, Popover coin view model. Let me open Popover, menu bar coin view model side by side. There are some code that I can copy in here. Okay, let's also import combine, import SwiftUI, declare a class Popover coin view model that conforms to the observable object protocol. Okay, and let's copy all of this. Okay, I think everything here we can copy. Okay, so for the publish property, let's change this name to title. Okay, this second one is value to subtitle, and this third one we're going to use coin types. This will drive the picker to select the coin type. It's going to be an array of coin type. And this app storage, please need to remove this private set here, as we are going to pass this as a binding to the picker. Okay, what else? I think for the currency formatter, we can display the full currency symbol. So let's remove this. Looks good. Let's also copy the initializer here. Let's change this color to coin types with the array of coin type. And let's pass the default value of CoinType.l cases. Okay, now let's change name to title, value to subtitle. change this also. Title, subtitle, and the color, coin types. Okay, let's try to build. Build succeeded. Okay, and let's implement the update view for the PopoverCoin view. Update view. And here we can simply get the coin also. Just let me copy this. It should be the same logic. Okay, and then I think in here we can use this logic. It will be the same. Just change this to title, subtitle. Okay, we don't need to show the use the connection state logic. Okay, and next is just to we only have this, right? We don't have that circle indicator. Next is also for each of the coin type inside the picker, right? We're also going to show the currency data, right? Current currency data in real time. So let's create a method value text for coin type. Okay. So given a coin type, the parameter will return the string containing the currency value, the formatted currency value. Okay. Here we can simply copy this. Okay, but this coin itself we're going to get this from the coin dictionary, passing coin type dot raw value. Okay, and here we're not going to set this, we're going to return the value, and here we're going to return updated. Okay. Okay, so next let's implement the subscribe to repository. This will be much simpler as we don't need to subscribe to service. Sorry, this will be much simpler as we don't need to combine two publishers. We just need to check the service dot coin dictionary subject and just sync this. Just ignore this and make sure to capture self as weak. Okay, just invoke self dot date view. Make sure to store the subscriptions. Okay, we have this thing. We can start implementing the MenuBarCoin View integration. Sorry, not MenuBar, PopoverCoin View. Okay, so let's declare a observe object var ViewModel with the type of PopoverCoin ViewModel. Okay, now we have this. Let's replace this Bitcoin hardcoded string with ViewModel.title and this one with ViewModel.subtitle. Now let's just make sure I'm not forgetting this at the on appear. Okay, so make sure to invoke ViewModel.subscribe to service. Okay, and let's implement the picker here. We already have all the components required. Declare a picker with the title of select coin. For the selection, we need to pass a binding. We need to pass a binding of this app storage. Selected coin type. Okay. Inside this view provider, let's declare a for each. Passing a view model dot coin types. Okay, let's name the parameter as type in here. And in here, let's declare a edge tag. Inside the edge tag, let's declare a text passing type dot description, and let's set the font as headline. After that, let's declare a spacer. Then let's declare another text. This time we're going to invoke view model value text for passing the coin type. So it can retrieve the current value for this particular coin type from the service dictionary, right? The CoinCap service. And let's set the frame with the alignment of trailing. Also set the font as body. Okay. And let's declare a link here, the button, so the user can click and navigate to Safari, passing the type.url. And we're going to use an image with SF symbol, passing Safari. Okay, we have this. Don't forget, we need to add the tag, and this tag needs to be using the same type as this CoinType ViewModel.CoinTypes element, which is we can just pass this type. Okay, now let's protocol hashable. Okay, I think that's not the error. First, let's add this modifier picker style, radio group picker style, and let's also hide this label. Okay, to avoid cluttering the UI using these labels hidden. Okay, now how can we basically react whenever the web storage changes? Basically, we can use this on change. Okay, parsing view model dot selected coin type. Okay, this will pass us the new value, but in this case, we are going to ignore the new value and simply update the view. Okay, whenever this coin type get updated, we're going just to update the view. Let's pass this view model here in the preview by initializing it. Let's pass Bitcoin subtitle $40,000. Let's ignore this. They already have the full value. Now we need to go to app delegate. Okay. Inside the app delegate, we need to declare another var PopoverCoin ViewModel, the type of PopoverCoin ViewModel, implicitly unwrapped. And here inside this setup popover, let's initialize this init. Pass the service CoinCapService, and here let's pass this ViewModel Popover Coin ViewModel. Let's build. Okay, but before we can test and run this, I think I forgot something inside the Popover Coin ViewModel in this subscribe to service. I forgot to add the receive on operator to make sure the subscriber receive the value in main thread to update the UI. Okay, let me also go to the menu bar coin view. So actually in here, this menu bar coin view should also add the on change modifier. So whenever the selected coin type app storage got updated, this should be invoked and we need to update the view with the new selected coin type. So we can simply pass selected coin type, and in the closure we can ignore the new value and simply invoke ViewModel.updateView. view. Okay, and let's try to build and run this. Okay, let me click on this menu bar item. Nice, it shows this pop overview with the title, subtitle, as well as the picker containing all the coin types. We can see each of the coin type shows the current currency value in real time. Let me try to change to the other coin type, selecting Ethereum. Nice, it got updated here as well as on the menu bar item. Dogecoin, Litecoin. Let me try to click on this link button. Okay, nice. It opened Safari. No, amazing. Let's select the other coin type, Ethereum. Okay, all of the links are working properly. And before we conclude, let's also test the monitoring of the network to see where the connection state got updated. Let me try to turn off my Wi-Fi. Okay, nice. It got updated. The circle color turned to red and this offline text is shown. Let me turn it back on. Give it a second. Okay, the circle turned back to green and we got all the new value from the server. That's it for this video. Congratulations! You have successfully built a macOS menu bar app with SwiftUI to track real-time crypto coin data using WebSocket persistent connection. I hope you have learned a lot of things from this video, so you can start practice and build your own macOS app that utilizes the menu bar UI. There are so many possibilities with the menu bar, as it is always visible in the screen for the user to see and monitor changes to a particular data, and there are so many other use cases that you can explore. And finally, let's keep on being a lifelong learner and see you in the next video. Subscribe to this channel and like this video if you love it. And finally, goodbye.